Hi, it's Jan Beta, and I'm going to build this OSA 2-button stick today from a kit that I received. It is the newest addition to the OSA sticks, the open source arcade sticks. Very much the size of a Competition Pro, has micro switches, and it has separate buttons. So you have a secondary fire button on this, which is pretty uncommon. The Competition Pros don't have that feature. You can also switch this. This has lit buttons, and you can switch the secondary button to the primary button. As of making this video, this is available both pre-made, fully assembled from dragonbox.de. I'm going to link that in the video description. And also the files to make this are openly available, as the name suggests. So you can print all these case parts at home, and there are some pre-fabricated parts that you would have to buy if you want to build this. It is going to be available as a kit if everything goes according to plan, so you can maybe use this video as the build instructions. I managed to build this. I'm recording this after building this, obviously. So let me take you back in time to the build process. Frank, who runs OSA-Stick.com, sent me this, and as usual I'm going to put links to everything you need in the video description. As I said, this is fully open source, so you can find all the 3D printed parts and a bill of materials and the circuit board that this includes in the video description. And there's also, of course, assembly instructions. I have them pulled up on my computer here, and I'm just going to go through them. This variant of the OSA sticks supposedly doesn't involve any soldering. It's all connectors that just plug in this variant. But I'm getting ahead of myself, so let's see how the assembly goes. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs. They also do CNC machining, 3D printing, sheet metal fabrication, injection molding. They offer populating your boards for you, and they have a new service that actually helps you design your boards in the first place. The pricing is super reasonable, quality is excellent, and if you want to build a project like the open source Joystick, I highly recommend you check out the link in the video description to order your parts from them. Back to our Joystick build. Yeah, this includes a lot of stuff. Some of these parts, especially the buttons and the micro switches, are of course off-the-shelf parts, but pretty much everything else you can 3D print and have your favorite manufacturer of PCBs make the PCB and things like that. You need some screws and some other parts, of course, but these case parts and the stick itself is 3D printed, and you have a little aluminum rod here, or aluminium if you like. Pretty cool. This also includes the tools, two little hex wrenches. Just going to set those aside, I guess. And then we're going to try to assemble this. And I'm just going by the instructions in the PDF file that goes with this. So should be relatively easy to do. Let's see. Yeah, and this might actually be important information in case you want to build one of these. This joystick is compatible with the C64, C128, VC20 or VIC-20, the Atari ST series, the Atari XL series, and I think the XE series has the exact same pinout, Atari VCS 2600, the Amigas, and the Master System. Okay, step one, we need these two switch covers here that we're going to place in these indentations on the lower half. So these are two plastic nubbins for the two switches on the circuit board. Then we need the circuit board itself. This is the circuit board, and it has some switches here, so we need to put this where the switches are and screw it down. Of course, if you're printing this yourself, you're going to have to melt these inserts in there. There are brass inserts for all of the screws. And yeah, you don't want to screw this down too much. just so that the switches grab reliably and are still movable. Yeah, looking good. So now we need this part here, and there's actually two different spring-loaded mechanisms that come with this. One is a bit softer. These are printed in flexible material. So I think I'm going to go with the red one. It feels a bit stiffer. The black one is a bit smoother, but I kind of like my joysticks to be stiff. So this has a little notch, or two of them, to position it so it doesn't rotate, which is pretty nice. Yeah, we turn it around. We are going to push the actuator into this. This is a square, and this has a square cutout, so yeah, that should be that. Okay, now we push our aluminum rod through here. Okay, so this is what we want basically, I think. This is our actuator protruding and our rod flat with this. Yeah, now we can screw down the set screw on this square part. I don't want to tighten it too much. Don't want the plastic to crack. Just hand tight basically. Yeah, feels good. The next step is going to be putting the buttons into the top half of the shell. These are our buttons and our top half. And we want these in here like so. So these contacts here face to the side. So something like this. And the other one. There we are. So now we want our stick part in here. Yeah, that feels about right. It's all loose, of course. And now we need to prepare our micro switches. So these need this contact bent a bit outwards. So I got my tiny pliers here. Something like that, I think. Maybe even a bit more. Yeah. This is so they fit the assembly later. Now we need this part here, and we need the shorter screws. We need to put these in here. And then we put our micro switches in there, like so. So now we need this distance plate. This adds to the stability of the whole thing. And now we're going to have to screw this into the case. So this needs to go top down, and then it goes in here. And we can screw it down. I'm also not screwing it down too tightly. At this point we already have the joystick mechanism, so that actually already clicks. Okay, wiring this up is the next part. These are already pre-crimped with all the correct connectors and things, so that's pretty helpful. We're going to need the red and black cables, and we're going to connect them. The red one to the positive on these smaller connectors here, and the black one to the negative. And these buttons have a little plus and a little minus on them. The left one is plus, that's our positive, and the right one is minus. And you're not supposed to push them in too hard. And there's another set of red and black cables that we have to connect to the other pins on the buttons. And these have to be bend over slightly. Otherwise it won't fit. Something like this. And the other one in the same way. It's easier to bend these if you bend them towards the side that has the roundings here. So something like this. We don't want to break these, of course. So that's that. Should look something like this. At least it looks the same in the manual. Oh, and I actually forgot one step on this microswitch assembly. That's actually the first thing, wiring this up. I think I can get away with using the blue and white wires now. These are the ones for the micro switches. Let's see if I can get them on there. The blue wire goes to the outer contact here, the one that we bent. And the white one goes to the middle contact. So, yeah, it would have been easier if I did this before. I didn't follow the instructions. So this is what we have now. We're going to pull the red and black cables through these notches here. So they are out of the way. And we're going to do the same with the blue and white cables on the top here. There we go. And there's another cable guide on the bottom here where we want to put the blue and white cables from the lower buttons, micro switches. Something like this. So now all our cabling is under some plastic nubbin so it doesn't get in the way. So now it's going to get a bit more fiddly. We're going to connect our micro switches to the PCB, and we're going to start with the ones on the right side here. And we have one shorter one that's going to this micro switch that is down. So we're going to put this through the second cable guide on the right and the other one as well through our cable guide. There's like little windows in there. So we're going to have to connect this one to down. That's the second connector from the right here. And this one is right. That's the fourth connector here. Like so, I think. Now we're going to do the same with the ones on the left. Second cable tunnel here from the left. So that's the third one here. And then we have one for up. That is the first one here. Okay, and that's our directional switches connected, hopefully correctly. But we can easily swap these in case something is wrong. So now we're going to do the same with the cables from the buttons. We're going to start with the ones on the right side here. And these go through the first tunnel here on the right side. And we want to connect the one with the bent connectors. That's the one for the actual switch, the button. And that goes into button 1 switch. This is the third one from the left here. Button 1 switch. And the other one also goes through the tunnel. And this one goes to button 1 LED. Like so. And basically the same thing on the left side. This is the one for the LEDs. That's this one here. And this is the one for the button, if I'm not mistaken. The one with the bent contacts. So this is the switch button 2. And now we should have all our connections in the right spots already. We just have to connect this to the outside world. And that is where our DE9 cable comes in. That already has a pre-wired crimped connector on here. And the red wire on here, in this case, goes to the position to the right, to the up connector. So this can be fed through this hole here. Yeah. This should already be a functioning joystick, if I wired everything up correctly. Now is the time to close this up. With all the wires routed somewhat nicely. Yeah, it closes up. So we are going to use the rubber feet, also 3D printed parts, and use the only screws that we have left, the longer M3 screws. These are 40mm M3s. And this is actually the second iteration of this kit already. These were originally just sticky feet, and this got changed to these 3D printed feet that you can just screw through here. Because the sticky ones didn't really hold. They were supposed to sit on top of the screws, but they didn't really last. And once again, you probably don't want to over tighten these. Okay, pretty nice so far. Let's put our stick on. That actually has another set screw here. It should go on here. Just going to put the set screw facing towards the cable, I guess. Looks really good. Closes up very nicely. Actually feels super sturdy. There's a lot of reinforcements in there. Even though this is 3D printed. Yeah, nice! Really cool joystick, feels good. And the little 3D printed rubber feet actually make this a lot less slippy. And of course we're going to have to peel the protective film from the buttons to see it in all its glory. And also we're going to have to connect it up to something and try it. Yeah, I fired up Turrican on my Crystal Amiga 500. Let's see if we get anything. Okay, the fire button seems to work. Don't have the lights activated yet, but I can do that. With this switch, I think? Yay! The lights up. Let's see if the joystick works. Yes, up, down, nice. And the secondary button also works. I can fire my laser thing here. That is really cool. So what does the other switch do? Ah, it just deactivates the secondary fire button. So I have this as a secondary fire button now. I can activate this stuff. That's actually really cool. I never played Turrican with 2 joystick buttons before. Believe it or not. Okay, the camera doesn't quite do it justice, but these fire buttons are actually lighting up. And I can turn this off just with the switch on this side, and this other switch on the bottom here just turns on and off the secondary fire button, which is this one then. Yeah, really cool joystick. It feels really good. Throw is kind of perfect. Feels good. Yeah, I guess that's it for today. As I said, everything you need to build one of these is going to be linked in the video description. Really fun build, really nice joystick, probably less expensive than getting a DE9 joystick, a used one or a new one from another source. And also you can, of course, have all the files and modify this to your liking and wire it up differently and things like that. Secondary joystick button. This is actually my first joystick that has a secondary button. Thank you so much for your time. Thanks, Frank, for sending this to me. It was a really fun build. Special thanks, as always, to everybody who supports me on Patreon or on Ko-fi or the YouTube channel memberships page. The links to that are on my website and in the video description in case you want to give me some support, which makes these kinds of videos possible. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye!